Fifth Pareto chart. Introduction. Welcome to this module on the fifth of the 7 QC tools, the Pareto chart. Based on the famous Pareto principle, this tool helps identify and focus on the vital few problems that cause the majority of effects. Definition and purpose. A Pareto chart is a combination of a bar graph and a line graph that shows the frequency or impact of problems in descending order. It's based on the 80-20 rule, which suggests that 80% of problems are often caused by just 20% of the causes. Why use a Pareto chart? Use a Pareto chart when you want to prioritize which problems to solve first. You need to identify the most frequent or costly issues. You aim to focus improvement efforts where they will have the biggest impact. Structure of a Pareto chart. A Pareto chart includes bars representing categories of problems or causes, arranged from highest to lowest frequency. A left y-axis showing the number or cost, frequency, defects, time lost, etc. A right y-axis showing the cumulative percentage. A line graph representing the cumulative total across the categories. Steps to construct a Pareto chart. Follow these steps to build a Pareto chart. Identify and list problems or causes. Collect data on the types of issues, like defect types, complaint categories, or downtime causes. Measure frequency or impact. Count how often each problem occurs or record the cost or time lost. Sort the data. Arrange the problems from the most frequent to the least frequent. Calculate cumulative percentage. For each category, calculate the cumulative percentage of the total. Draw the chart. Plot bars for each category on the left y-axis and a cumulative percentage line on the right y-axis. Example scenario. Let's say a manufacturing team tracks 100 defects in a month. They find that 45 are scratched surfaces, 25 are loose parts, 15 are missing labels, and 15 are other. When plotted on a Pareto chart, it becomes clear that scratched surfaces alone account for 45% of all defects. Addressing this one issue could nearly cut defects in half. That's the power of Pareto. Benefits of using a Pareto chart. The Pareto chart helps you focus on the most significant problems first. Use limited resources more effectively. Communicate priorities clearly with visual impact. Track improvement results by comparing charts before and after changes. Common mistakes to avoid. Here are some mistakes to watch out for. Not collecting enough data to reveal real trends. Grouping unrelated issues under other too often. Forgetting to update the chart after improvements. Tips for effective use. To get the best results from a Pareto chart, focus on frequency or cost depending on your goal. Break large problems into sub-causes for deeper analysis. Combine with other tools like the cause and effect diagram to investigate root causes. Summary. To summarize, a Pareto chart is a decision-making tool that visually separates the vital few from the trivial many. It's based on real data and helps prioritize problems that will have the greatest impact if solved. It supports smarter, more focused quality improvement. Call to action. Next time you're overwhelmed with many issues, use a Pareto chart to guide your focus. Fix the big hitters first and watch your quality and efficiency improve faster. Sixth, scatter diagram. Introduction. A scatter diagram is a simple yet effective visual tool used to explore the relationship between two variables. Definition and purpose. A scatter diagram is a graph that shows how two variables are related by plotting data points on a two-dimensional axis. It helps answer questions like, is there a correlation between two variables? Does one variable increase or decrease as the other changes? How strong is the relationship? Why use a scatter diagram? Scatter diagrams are used when you want to study and identify the relationship between two variables. You suspect that one factor affects another, such as temperature and machine performance. You want to visually assess correlation, positive, negative, or none. Basic components of a scatter diagram. Let's break down the scatter diagram. The x-axis represents the independent variable, input or cause. The y-axis represents the dependent variable, output or effect. Each point represents a pair of values, one from each variable. Steps to create a scatter diagram. Identify variables. Decide which two variables you want to examine. For example, temperature and product quality. Collect paired data. Record measurements in pairs such as temperature, quality rating. Plot data on a graph. Place each pair as a point on a graph, the x-coordinate from one variable, the y-coordinate from the other. Analyze the pattern. Look for trends or patterns to understand the relationship. Example scenario. Let's take an example. A quality engineer wants to find out if machine temperature affects product defects. They record the temperature and number of defects across several days. When they plot the data, they notice that higher temperatures are associated with more defects, indicating a possible positive correlation. Types of correlation in scatter diagrams. Scatter diagrams can show different types of relationships. Positive correlation. As one variable increases, so does the other. The points trend upward. Negative correlation. As one variable increases, the other decreases. The points trend downward. No correlation. There's no clear pattern. The points are scattered randomly. Strong versus weak correlation. The closeness of points to a straight line indicates the strength of the relationship. Benefits of using scatter diagrams. Scatter diagrams offer several benefits. Help visualize relationships between variables. Support root cause analysis. Assist in identifying trends or potential causes of variation. Can guide further statistical analysis, like regression. Common mistakes to avoid. Avoid these errors when using scatter diagrams. Confusing correlation with causation. Just because two variables are related doesn't mean one causes the other. Using unrelated variables. Ensure there's a logical reason to compare them. Plotting inconsistent or unpaired data points. Summary to summarize. A scatter diagram helps identify and visualize relationships between two variables. It can show trends, correlations, or the absence of any relationship. It's an essential tool in data analysis and problem solving. Call to action. Next time you're exploring a potential cause and effect relationship in your process, try using a scatter diagram. It's a great starting point for deeper analysis and better decision-making. 7. Flowchart. Introduction. Welcome to this module on the 7th and final QC tool, the flowchart, also known as a process diagram. A flowchart is a powerful tool used to visualize the steps in a process and understand how work flows. Definition and purpose. A flowchart is a graphical representation of a process, showing the sequence of steps using standardized symbols. It helps answer questions like, what are the steps involved in a process? Where are the decision points, delays, or loops? Are there any unnecessary or redundant steps? Why use a flowchart? Flowcharts are used when you want to document, understand, or improve a process. You need to identify bottlenecks, inefficiencies, or quality risks. You are planning training, audits, or standard operating procedures. You're communicating a process clearly across teams. Basic components of a flowchart. Let's look at the key components. Terminator, oval, indicates the start or end of a process. Process, rectangle, a task or activity performed. Decision, diamond, a point where a decision must be made, leading to different outcomes. Arrows, show the flow or direction from one step to the next. Steps to create a flowchart. Define the process. Select a process that needs to be documented or analyzed. Identify the steps. List all the activities, tasks, and decision points involved in the process. Sequence the steps. Arrange the steps in logical order from start to finish. Draw the flowchart. Use standard symbols to map out the process, connecting them with arrows. Review and improve. Validate the chart with process owners and look for opportunities to streamline. Example scenario. Let's say we want to map the process of handling a customer complaint. Steps might include receiving the complaint, logging it into the system, analyzing the issue, taking corrective action, following up with the customer. Each step is represented using the appropriate symbols, showing how the complaint moves through the system. Types of flowcharts. There are different types of flowcharts depending on the level of detail needed. High-level macro flowchart shows the major steps in a broad overview. Detailed micro flowchart breaks down every step, including sub-processes and decision points. Swim lane flow chart divides steps by departments or roles to show who does what in a process. Benefits of using flowcharts. Flowcharts provide many advantages. Clarify complex processes and improve understanding. Identify waste, duplication, or unnecessary steps. Support training, standardization, and quality improvements. Serve as a foundation for process audits or root cause analysis. Common mistakes to avoid. Be cautious of these common errors. Missing steps or decision points. Incorrect or inconsistent use of symbols. Not involving the right stakeholders in creating or validating the chart. Overcomplicating the diagram with too much detail in one chart. Summary to summarize. A flowchart is a visual map of a process, helping teams understand and improve their workflows. It uses standardized symbols to represent tasks, decisions, and process flow. It's a fundamental tool for process documentation, problem solving, and quality control. Call to action. Try creating a flowchart for a process you work with every day. You might be surprised at what you discover and how easy it becomes to improve it.